Okay, now it
Thanks,
started.
Jane.
It just
Okay.
started.
Cool. Welcome, everybody. This is Bill Bain, the Managing Director of Smart Cities Council. We're all laughing because I've been going on for about 4 minutes about what we're doing. And I have a real hard time figuring out that start button, so I apologize. What I'm going to do now is this slide deck that I was quickly going to go through. You can download, you can look at it. It essentially lays out our goals, the cities that we're currently interviewing to be finalists or to be leaders of readiness cohorts starting in 2021. A lot of interesting projects, over 40 projects on the website that you can look at. If you download this, you can see where you can vote for a project. You can also see where you can find out about the projects themselves. Today, we're talking with Nashville. What you're looking at is a screenshot of our activator roadmap for Nashville, which will be delivered to them in February, and which other cities can get access to for free. Cities have free access to the Smart Cities Council activator. Today is the 6th session, and we're talking about data modeling. We've already reviewed sensors. We've reviewed needs from Nashville. And then we're going to be working in January to review the needs of vulnerable communities, collect data. Dr. Camp from Vanderbilt University is an expert here and is going to be helping us. And then in February, we'll finalize the roadmap and deliver it to Nashville for use. So with that, I'm going to introduce our speakers from Hydromet, Mike Casey and Chuck Carrozza. Chuck, if you want to, I'm going to give you the screen and you can get started.
All right, so looking for that screen grab.
Yep, give me a second. There we go. You see it?
Yep. All right, so can someone confirm you can see my screen?
Yes, we can see your presentation.
Excellent. All right, well, thank you, everyone, and thank you, Philip. It's wonderful to join everyone this morning and have an opportunity to talk. The agenda between Mike and I will be as follows. I'm going to do a very quick intro to Hydromet, for those that may not be familiar. Then we're actually going to do a kind of a follow the data. So we're going to start with the sensors, work through the equipment components quickly, review, and then get to the platform integration analytics, the software. Mike will then. So, who we are, Hydromet. So as you can see by the diagram, we have a number of product families that address hydrology and metallurgy, and that pertains to water quality, water quantity, data loggers, telemetry, and of course, flood warning, flood alert. And that includes the software manipulation, analytics of the data. And for clarity, AQUATIS is now a part of the Hydromet family. So that explains why Mike and I are jointly presenting, and he's presenting on the software component, but we are together as a group to support your efforts here. Just for one more experience slide. So on Hydromet, we do surface water quantity, flood warning, groundwater level monitoring, and water quality. So I thought probably one of the best ways to begin in the details is to talk about what a particular city, Harris County, you'll recognize Houston, Texas, what they put together for a flood warning system. So the challenge they had, 1,500 miles of open channel drainage, 3.7 million people, and they needed to protect both the infrastructure and the people and have a robust flood warning system. So what was put together was our sensors, the RLS radar level sensor and a compact bubbler sensor. And that was combined with a Campbell Scientific data logger. And then Harris County used the Alert 2 warning system. The thing I want to highlight is that Harris County, this was an interagency collaboration. 9 different agencies, multiple equipment vendors. Way back in '82, there were 13 stations. Fast forward, there's well over 153 stations in the county. And this is a screenshot from yesterday showing the rainfall in the past 4 hours. So thinking ahead for when Mike talks about the software, the data that is coming from this network is coming from our sensors, competitors' data logger, from Harris County's own stations, from stations data being pulled in from USGS and others. So there's a spectrum of information coming from different equipment, different data platforms and file types that the platform, the software for conducting analytics and evaluating needs they be able to handle. So what you'll note in the previous slide on the sensors was, and when we get to the components of the flood warning system here, I don't want to reinvent the wheel. I know the past discussions, webinars have focused on this, but there's a few items I want to highlight. So with Harris County, they used what I guess we've been calling in this webinar series scientific sensors, the high accuracy sensors. They used it across the entire region, as well as, of course, pulling from USGS, which would also be using those high accuracy, what's been called scientific sensors. The reason I bring this up is I know the theme in the last webinar on sensors was on the ultrasonic sensors and what was labeled as commercial sensors. I want to throw out the idea for discussion when you're looking at a region that you want to monitor for flood warning. It shouldn't necessarily be an all or nothing between commercial and scientific. If you place the high accuracy sensors, a few of them throughout the region, and then fill in the gaps with the commercial grade sensors, then you have the benefits of both. You have the economics of the commercial grade as well as the data, and then you have the high accuracy, which can be used as a high level platform for your model and predictions, and also as a check on the other sensors. And lastly, you may have specific flood locations that will flood with a small change in water level or a small change in the rise rate. That sensitivity may require a higher accuracy sensor. So again, I throw out the idea that when you're looking to develop a flood warning system across the region, the benefits of both types of sensors, commercial and scientific, may have merit. Again, various components of the flood warning system. I do want to spend a little time on the data logger. Telemetry, which in most cases would be cellular, that would send the data to the computer, to your phone, and to the software that Mike will speak on. So before we get to data loggers, the sensors, the high accuracy sensors, this is a RLS radar level sensor, typically be mounted on a bridge, and it would be above the floodplain, so there's minimal risk during flooding to the sensor, so low maintenance, rise calibrated. Alternatively, if you don't have, for example, a bridge to mount on, you have the pressure level sensor, which goes directly into the water. This particular model has a ceramic membrane for increased durability. And these type of sensors have been used, for example, by the USGS for years, and they're meant to be durable for years. This is a new item that is a kind of an option 3. This is an all-in-one EcoLog 1000. It has the water level sensor, the data logger, and the modem. So it's an all-in-one package, for example, for quick deployment. The only thing you need, of course, is a cellular signal and a cellular plan. And if you're looking, again, as the last slide on the sensors, if you're looking to complement your flood alert system with precipitation gauges, this is another example where high accuracy gauges complement the more economical gauges. I'll cite an example. In Ohio, the USGS was looking to monitor the precipitation in the region. And so they purchased a couple, I think 3 pluvios, which is a very high accurate standard for precipitation measurement. The accuracy is plus or minus 0.004 inches on the measurement. But it's a premium product. So they bought enough as an accuracy baseline in the region, and then in between, they filled the gaps in the region with a economical tipping bind, which was lower in accuracy, but still provided relevant data to map out the region. All the sensors would be connected to a data logger. In the case of Harris County, it was connected to a competitor's data logger from Campbell Scientific, but they are interchangeable with communication, the same communication protocols. The advantage of the data logger is it's basically the brains of the operation. It controls the data monitoring frequency. It controls the data transmission to your database, to your computer, and it has custom programming. So that you have a complete control on how your flood monitoring and your alert system works. An example, you could have the scripting on the data logger say, measure and transmit the data once per hour. So every hour you get a water level measurement, and that would be transmitted to your phone, to your laptop, your desktop. Except when the water level exceeds a threshold. Now measure every 15 minutes and transmit every 15 minutes. This could be considered the yellow phase of a flood event. You're approaching it, but it's not at a critical moment yet. Now, situation number 3, you've exceeded a water level threshold number 2. Now, measure the data every 5 minutes, transmit every 5 minutes, and send alert out to first responders and other designated individuals, i.e. you're in a flood situation or you're approaching a flood situation. So that is a custom logic that you put on a data logger that can be made to perfectly fit the local situation. So the data logger has collected the data and transmits it to you. And this is where, again, like with Harris County, that data is coming from multiple stations, different equipment, possibly different file formats. So now you need a software package that can handle and integrate and conduct analytics and all that different information. So this is where in the timeline, Mike will have a lot of good things to say about this aspect.
Yes.
Mike, I'll just tell me when to fast forward the slide.
I will. Thanks.
Hey, Chuck, this is Philip, though. I had a question.
Yes.
I really appreciated the fact that, so in Harris County, you had multiple solution providers and you were collecting data from multiple ones. So your system can work with multiple solution providers, correct?
Absolutely. So our sensors are equivalent competitor sensors, as well as the data loggers. They all have the same communication protocols. So yes, they will play nice with each other. Like in Harris County, it was our sensors, but a competitor's DATALOGGER. And that situation could have been reversed. It could have been our DATALOGGER and their sensors, and they still would have worked.
Yeah, that's really important because obviously in the public sector, cost is a real issue, and people want to evolve as opposed to rip and replace. So the fact that you can make the system better with key components and work with other solution providers is really a good feature. Thank you for that.
Yes.
Go ahead, Mike. I'm sorry.
Oh, no worries, Philip. Thank you very much. And Chuck, thank you, and the city of Nashville. Really appreciate the opportunity to spend a couple of minutes talking about what to do with all the data that you're going to be collecting. So I am Mike Casey. I am from AQUATIC Informatics. We are the One Water platform. If you can go to the next slide, Chuck. We are purpose-built for water data management and actionable intelligence. AQUATIC Informatics is now part of the Danaher company, portfolio of companies, falling into the Danaher water quality platform. So as you see here is kind of our water wheel of Danaher water quality platform companies in different brands that operate, in whether it's in the natural environment, stormwater, drinking water, fats, oil, and grease, industrial pretreatment. We have an opportunity to connect and integrate all the different various water data sources that a city like Nashville will be collecting. But today we're going to be talking about AQUATIS. AQUATIS is purpose-built for environmental data management. We have visualization tools to contextualize current values to historic conditions. So what that means is as incoming data is coming in off of your data loggers, we have the ability to take a look at what's going on historically and be able to make actionable decisions based off of those real-time conditions benchmarked against historical conditions. So if you can go to the next slide, Chuck. So when we talk about deploying a flood monitoring and flood warning system, it really starts, at Chuck's level with the physical sensors in the field, making sure that they are deployed in the right spots. The sensing and controls are primed and ready to go. The collection and communication, making sure that that data is transmitting. And then once that data is transmitting, it comes into a system like AQUATIS where it's, you can manage it and display the data from all of your disparate data sources. So Chuck had said, it's a combination of all these different pieces working together for a single flood warning system. AQUATIS can kind of connect the pipes to all those different sensors and loggers, centralize that into one single application, and then make that available out to both internal and external stakeholders for warning, for further analysis, for research purposes. But it's all about collecting and organizing the way to get that data prepped and ready to go, so you can start looking at predictive analytics, in other systems that will help you dive deeper into the data that you're collecting. So next slide, Chuck. So we are purpose-built again for the water industry. We can go to the next one. And I just wanted to show you what the water platform is, and we'll just take a quick tour through this. So on the left-hand side, you have your sensor data, and you have other data, whether it's your discrete sampling data, water quality data, and other collection agencies. As a matter of fact, a lot of my customers not only use the monitoring network that they're invested in collecting data from, but they incorporate other data sources, including MET data, USGS data, any sort of time series or value that will help them get a more holistic view of what's going on in their watershed, both historically and in real-time conditions. All of that data is processed through the AQUATIS time series engine. And through there, we're able to incorporate all the modeling software, all the asset tracking, the web publishing, and then it transforms that data and sends it out to the public through the AQUATIS web portal or any other applications that you might deploy internally. So again, we're not really, when we talk about AQUATIS as a platform, yes, we are part of the Hydromet family of companies, but really we're able to connect to all of your disparate data sensors and other information that's out there that again will help you make a better informed decisions in near real time. So if you can go to the next one. So visualization for faster decision making. AQUATIS is used by governments to determine who goes out to do spot checks for OEM management, for any other decision making about what's going on in the watershed, to citizens as alert notifications. They can log on to the public platform. They can view the QA/QC data and the corrected data, and pull research files down, and then operations as well. So it really is a true enterprise class software application where it's used by multiple disparate organizations, all using the same platform for the same decision-making capabilities that they're responsible for. So next slide, please. So AQUATIS has built-in alerting capabilities. So with the ability to monitor real-time conditions throughout your entire monitoring network. The user defines the gauges and values, what constitutes a green, yellow, or red situation. You can customize your flood states, and also what's a lot of my hydrologists use it for is to identify signal strength. So if they notice that hey, one of my stations is offline, or it's transmitting data that isn't congruent with what else is going on in the watershed, let's send somebody out there to take a look at that. So it's not only for OEM capabilities, it's also for water resources to make sure that the health and safety of your network is actually running at capacity. So the next slide. Chuck, can we get the next one?
Needs to be frozen.
No, okay. Well, I think while we work that out,
hey, Mike, this is Phil. Phil. Let me ask you a question.
Sure.
So I'm fielding a couple of questions from, and we're here to help Nashville, so we're pretty direct. So we've seen these platforms, like for instance, Carey had a platform where they were using multiple solution providers, and then they were using Salesforce for alerting. So what you're saying here is that your platform also includes the alerting also to citizens?
Yes, well, not directly to citizens. It is part of an SMS network. You can, if you had every citizen's phone number in order to ping them regarding flood warning conditions, you'd have the ability to do that. We can also send out notifications, but primarily like the Toronto Regional Conservation Authority, it's they have a tiered warning system. So first it goes to the water resources, and then it's escalated to OEM, and from there they make the decisions whether to reroute ambulances or close down roads. But through the public display portal, you can log on to, if anybody wanted to go to the city of Orlando, hydrology.orlando.gov, and you can see how they use their web portal to show real-time conditions at the various gauging stations that are feeding the model here.
You may want to type that website into the chat box so that people can access it while we're talking.
Absolutely.
Philip, this
Chuck,
is Brad.
Go ahead.
Oh, sorry. So I have a question. When you're pushing out information to the public and considering that, is there any QA/QC or consideration about what's being pushed out or made publicly available?
At 100%. So before it's pushed out to the public, it's actually run through the AQUATIS time series, which is our QA/QC engine. And so before, and it's entirely up to the end user or the organization whether they want to send out provision data. Okay, there's a warning screen saying, hey, this data has not been looked at, but we have a 1 minute gauge to page, and just to let you know we haven't QA/QC'd it, or you can hold it back, run it through the QA/QC process, and then publish. It's 100% up to you.
Okay, and kind of a follow-on question, how are you managing like the hierarchy of who has access to certain data?
Absolutely. It is all based on credentialed access.
Okay.
So there's two different ways of displaying your data. One is through anonymous public access, meaning, hey, these are the parameters that I'm going to show, these are the values that I'm going to show, and anybody can log on like the Orlando example. You can also,
And Mike, I've just thrown up the City of Orlando
Sure,
webpage
thank
you were
you.
talking about so that people can see it.
Yes,
It's always,
absolutely.
you know, we're big about getting our hands dirty here. So
Oh, absolutely. I appreciate that. So you can look, and if you go down to select a parameter on the top left-hand side of the screen, there's all the different displays that Orlando is allowing the public to do. So, now Orlando also uses this to share information back and forth to other stakeholders within the organization. So there are certain dashboards and screens that are only available depending on what your credentialed access is, right? So my case at Aquatic Informatics, I would type in my password, and I might have a completely different user experience than, say, Mike Casey, anonymous public user that's looking at this right now. So the long and short of it is, you drive what the public sees, you drive what internal people see. It's entirely up to you on how to configure the web portal. And we've worked with hundreds of organizations to, build, to essentially help them configure their portal to really get the most out of it.
Okay, sorry, I've got so many questions.
Oh my gosh,
Jamie
good,
again.
I like it.
hey,
Can
Janie,
you,
just introduce yourself so Mike
oh,
understands where you're coming from. Yeah.
yeah,
Good.
sorry, Mike. I'm a research associate professor in civil and
Sure.
environmental engineering at Vanderbilt
It's very
University.
nice to meet you.
Nice to meet you. And so a lot of what I do is thinking about how we take data and information, convert it into tools that stakeholders and public officials, state government agencies, and others can use. Kind of thinking about data that exists that, often we're just thinking about how best can we use that to inform the decisions and what do the stakeholders need. And so I've worked with the city of Nashville on various things in the past. I know Jennifer Higgs is on and may have questions, but can you speak also to kind of level of effort? Who's doing the heavy lift on this? Is this you all? Is it the city that you're working with?
It's the city, yes, and it's very much a collaborative partnership to make a project like this run. It's enterprise software. It's not. We offer a turnkey commercial off-the-shelf solution, but each city, each agency, each department really within an agency has their different set of priorities, workflow processes, designations. So it's not a Herculean effort to get these things off of the ground, but it does take a lot of collaboration and dedication in order to really beef this up, because what we're talking about is we are going out to all these different data sources and making sure that the pipes are all connected to feed that data into Aquarius. And then once it's in Aquarius, what the heck are we going to do with it? Who's responsible for QA, QCing and provisioning the data, grading the data? Who's responsible, for giving the final sign off? I've met with hundreds of water quality professionals that have multiple layers of approvals and workflow processes that each data set has to go through in order for it to be, into their final report. So, Aquarius is a large enough, flexible enough program to support those efforts. For example, the USGS. The USGS has 16,500 staging gauges throughout the United States. All that data, at once every 5 minutes, all that data is pinging a server in which Aquarius is running and processing all of that data. And then they use their own proprietary website to publish that, the NWIS system. But all of that data has been run through our calculation engine before it meets the public. So
Awesome. That's
Hey,
good.
Mike, in regard to that, and maybe Chuck will help here too, Roger Lindsay from Nashville had a question. What's the mix of scientific, because you mentioned USGS, what's the mix of scientific and commercial sensors? Because we all know the scientific tend to be more expensive. Have you guys seen anything a best practice in all your work?
You know, that's a great question, Phil. We are hardware agnostic. So our company line is if the data is available to get it, bring it on it. So whether that's telemeter data out in the field that's coming in and we're grabbing that, bringing it in from all these different sources like USGS, or I work with, you know, a small consultancy firm in Northern Ontario. They have 6 streaming gauges and they go out once every 4 weeks and they do a manual data pull of the data, bring it back to the lab, and then dump it into Aquarius, and then they do they start their workflow process. It doesn't matter to us. So what we're finding is that with the IoT, with, you know, the sensors becoming, you know, cheaper, which they are, and more deployed, what that does is it's a perfect opportunity for us because now you have 10x the amount of data that was coming in before, and time series data doesn't stop. And once you turn that pipe on, it just keeps on going, keeps on going, keeps on going. You need a way to get a handle on that, and that's really the power of Aquarius comes into play.
And one of the questions from Jennifer Higgs was that, so on the Aquarius platform, do you have an API also where it could link to other portals or like open data? Well, that's why Jennifer asked.
Absolutely wonderful question. I absolutely love this question. The short answer is yes. So we use RESTful APIs. So Aquarius has all these wonderful tools specific to the water industry, QA, QC, statistics, daily means, all these different derived calculations that you can do, all this really cool stuff. What we're not is, let's say, a quote unquote pure play stats company like SAS or like R or like Power BI. So what we do is, you know, with a little bit of engineering chops, we have an open API. Now we can start taking data with a click of the button, moving it through the pipe into, let's say, SAS, because they're presenting after this. SAS runs their complex calculations and then pulls it back into Aquarius as a derived time series. So there's all these different fun things that we can do. And I used to, in the early aughts, I used to work for SPSS, which is a competitor of SAS. It's now an IBM company. And one of the things that we would always talk about, it's a garbage in, garbage out theory of data management. Aquarius doesn't compete with SAS. We don't compete with SPSS. We don't compete with R or Power BI. Aquarius complements it. What we do is we organize the data in such a way that, and run it through the cleansing process, such a way that now you have clean, defensible data to feed your models, to make your reports, and that's what it is. It's all about clean, defensible data that's really spawned us into this huge company. So it's pretty neat.
No, that's really insightful, and I appreciate that. So with that, are there any other questions for Chuck or Mike before Brad takes over? From anybody? Go ahead.
Just kind of in summary, I guess the way I see what Aquarius does is a date. And correct me if I'm wrong here, but just kind of in simple terms, Aquarius is a data curation and management platform.
I like intelligence, but yes, you are right. It is, yes, to a certain extent. And Jane, we can always talk about this offline. My contact information is here. What we can do is we can have a more informed discussion about the data that you're collecting. Right now, very, very high level. We had 10 minutes and the presentation stopped halfway through it.
Right.
But I think this is a lot more beneficial to, at least give us a chance to explain what Aquarius does. I know that, there's a little bit of a reticence based on prior conversations about having a single vendor to manage all of your entire flood monitoring network. We get it. We rarely see any water resources agency that has a single vendor, right? All their eggs in one basket. Aquarius helps tie all those knots together and turns that data into, again, actionable intelligence. So thank you, everybody, for the opportunity to present today. I really appreciate it.
Thank you.
No, we really appreciate it, and especially we appreciate your openness and Chuck's openness to questions. And because this really is about accelerating the delivery of benefits for Nashville. And to do that, we got to ask some of these hard questions. Thanks a lot, Mike. Really appreciate it. Thanks, Chuck. Now, hey, Brad, I'm going to give you
Thank you, everybody.
the screen.
Okay, very good. Appreciate it. And let me just bring up my screen here.
And we can see your screen.
Okay, very good. Let me put it in presentation mode and go through it. So yeah, appreciate it. Good to talk with you all today. My name is Brad Clens. I work at SAS in our IoT division. And I'm going to go through a project that we worked on with Town of Cary and just about that specific implementation and the kind of larger solution around it. I believe you all had a discussion with Terry Yates from Town of Cary previously.
We did, Brad, and it was really, it was
Okay.
a great presentation, and you guys were part of it. So yeah, appreciate you using that as a case study.
Okay, yeah, most definitely. And I'm definitely willing to take questions as we go through about aspects of the project or what, you know, or what we did. Kind of just an agenda that I've got set up for today. I'm going to talk about the use case that we did and the project objectives, also then about how we went and built it, and then kind of dive down a little bit more into the data that we get and the analytics techniques that we used to get the results that we have. I gave the slide deck. I sent the slide deck in. You'll all be able to get a copy of it. I put this in here. I like this because when we had our kind of our kickoff and brainstorming session, we went through and just tried to capture all the different things that we were trying to achieve. And this might be helpful for you all as you start to work on this kind of project, just to give you an idea of you know, some of the things that we were looking at. And you know, a big part of it was, you know, improving situational awareness for the stormwater department and the operations people. You know, a lot to drive low response time and increase efficiency in responding to things. Definitely wanted to also, you know, tie it in with our mechanisms to communicate with our citizens. And then another part that we had, and we touched on it a little bit ago about data sharing and open API, is within our, we have a good regional team here. And so we wanted, because obviously the streams and rivers, you know, flow between communities, we wanted to share the data between them and also back to the state. So that was important for us. And then to achieve some of these objectives, we had different analytic models that we wanted to create. And I'll talk about those in more detail as well. Just to give you an idea of the implementation and the watershed that we implemented on, this is in downtown Cary, and you start to see where we map out the watershed. We've got a mix of sensors, like we've talked about previously, where we have the ultrasonic flood level gauges to measure the water levels. We have various types of rain gauges. And then another thing that we did here to get more coverage, and I'll go into this more, is make use of a weather service to get more granular rainfall estimates, both for the current time and also for the future, so that we could be more proactive in the solutions that we have. And I'll go into that in more detail. But just to give you an idea of, you know, what it looks like in terms of the dashboard, these screens are geared more toward, you know, like the stormwater management department, and then, you know, possibly some of the operational and you know, control center type folks. So, you know, with that first objective of, you know, having situational awareness, you know, bringing up a map, a GIS map that has all the different locations on there, where the current readings are, both the water levels and rain gauges that we, rainfall amounts that we're seeing. We've got that. You can drill into any of these and get more detail, both flood levels and everything like that. And then you can start to also drill down onto the individual gauges to see, you know, when something catches your eye. And you know, this shows the past 24 hours of the the flood levels at the different stages. We normalized it to stage levels based on that. And then also on the right-hand side, you'll see we go ahead and use that forecast data that we're getting to forecast the flood levels at each location. So the key part here is that we're able to do everything very localized. You know, it's previously in town Cary, there was one U.S. Geological Survey gauge that had some impact on part of their watershed. And now we're mapping out that entire watershed, you know, at a very much more granular level and able to do that pretty effectively. Another part, you know, because we're capturing all this data, we want to be able to go back and look at it and understand more what's going on. This is at the stream level gauges, and here you start to see some of the things I'm going to talk about, anomaly detection, where you see in certain cases the water levels are correlated, which shows, you know, gives you some good feedback on what the water flows are for different rain events. But then you see some unusual ones popping up, and that gives you an idea of where you need to look into where there might be different issues. And those issues could be things like something's blocking part of the waterway, or in front of a culvert getting jammed up, or something like that, or maybe the gauge itself is having trouble. So we can identify those and look into them. So that's kind of what we, you know, kind of how we take the data and the analytic results and present it out there so that you can action on it. I can take any questions if you have on that right away, or I'll go into a little bit on how we build this out.
So, Brad, I had a question on the slides you had. You were running a predictive element, which is you, like on the last slide or the slide before, you had the 24 hours and then you had the next 6 hours.
Correct.
What kind of data are you using? I mean, so you're capturing the data, and I remember the architecture from what Terry presented, and the way Terry presented it is once the data is captured, it went through part of Azure, but it went to Esri for sort of real-time reporting, but then it went to you guys for the predictive reporting. So
Correct.
what kind of, so with the idea that you're getting data from the sensors for the real-time reporting, what kind of data are you using for the predictive reporting?
Yeah, it's a little both. We so the predictive is because we have the historical data, and we can see, you know, from previous, you know, rainfall events, when we, you know, because we have that real localized gauge system in there, we can see that, you know, okay, when we get rain on this part of town, here's how it affects this part of the watershed and this part in the river. And so we use that historical data and discover and model all those very, you know, localized relationships. But then in the real-time aspect, we're not only getting the current data, but then we have the weather service. This is provided through Azure Maps API to AccuWeather, where we can get the future rainfall estimates for specific locations. And because we know if we get X amount of data in this area and X amount of data, X amount of rain in this area and that area, we normally see this amount of flood level in this area. That's how we do those predictions.
So you're using both historical and weather-based data sets to then model a predictive on that particular situation, the existing, you know, reporting.
Mm-hmm, correct.
Okay, cool.
So,
okay, great.
So Brad, this is Roger.
Go ahead.
Roger. The use of a predictive rainfall data, we've begun to rely on the Weather Service's QPFs, the quantitative precipitation forecasts that are available at any given moment for, you know, the next 24 hours or 48 hours or 72 hours or whatever, and they're often broken down into much smaller increments. And so we rely on those. That data is massaged through a HEC real-time simulation model, and it allows us, as you've described, it allows us to look at what's rain that's already on the ground in the creeks, in the rivers, plus the incorporation of the quantitative precipitation forecast. We know what we expect in the next 6 hours and 12 hours and 18 hours. And so it allows us to kind of key on basins within our system that might be targets for maybe excessive or flood level water levels. So it sounds like you're using something maybe similar to those QPFs to feed that predictive rain information.
Correct. Yeah, and like I mentioned, we're the weather service that we're making use of through Microsoft is AccuWeather, and it allows you to, and this is, I've gone back and forth with the folks at AccuWeather, and I wanted to spend more time drilling down in more detail as well, because what they do is they give the rainfall estimates for particular locations. You can call into that location, you specify the location that you want, and it's not just for this city or whatever, it's by latitude and longitude. Now what I did was we broke it out into basically square mile areas to get those estimates, and I wanted to start working with it at that level and then look at different granularities both in size, area, as well as time frequency, how often you want to catch. But yeah, we are capturing the effects of, okay, in this part of town we expect to get this amount of rain, in this part of town we expect to get a lesser amount of rain, and then how does that flow into the creek.
Okay, thank you.
So I think, Janie, did you get your modeling question answered?
Kind of. So you're not doing any like long-term predictive modeling based on climate data or anything like that. You're taking empirical historical data and estimated near-term precipitation amounts and kind of meshing those up based on, like, you've got a database of, if we have 8 inches of precipitation here, this is what the flood level or water levels would be. And so you're essentially kind of doing, longitudinal linear regression maybe of matching up and saying, oh, well, it should be about this level here because we have that level of precipitation. So you're not doing like hydro modeling or statistical modeling. It's just kind of a more, we know this level of precipitation leads to this level of flooding, correct?
Well, it's along that lines.
Okay.
It is definitely statistical and analytic modeling that we're doing here. And the hydraulical modeling is something that is kind of captured tangentially through there, because we've got the good gauge system. It starts to capture, some of the topology effects in there in terms of, okay, when we get the rain here, it flows down into this area because we have all that historical data. So it starts to capture that, implicitly, but it can be combined. We've done some things with, we use, as far as stormwater planning, the SWIM model from EPA, where you can kind of say, map out your watershed, your catch basins, and your infrastructure and everything. You can kind of take and combine that simulation data with the real world sensor data to augment those two.
Okay, that makes sense. Thank you.
Jennifer, you had a question about staffing this up. Do you want to ask that? I hesitate to ask because I'm not sure exactly what you mean. Maybe you could ask that.
So you're using sensors, a variety of sensors out there, and you're monitoring them. Is this someone in your IT department that you have keep making sure the system and everything's working? Is that how many staff people does it take? Right now we rely on all our data to be from USGS gauges, and they're monitoring all their gauges and making sure they're working. How much staff does it take when you now start implementing other sensors in addition to?
Yeah, we had we had a vendor that does the installation and maintenance on the sensors, but then as far as kind of monitoring and more tactical things, it's the stormwater operations public works department that would go out there, and one of the parts I mentioned, and I can talk about more, is this anomaly detection model that we do. And one good thing about that in terms of the staffing is it's running, consistently. And what you find is, so when you have minor events, minor rainfall and things like that, we're watching all that water go through there. You can tell from the forecast, this is not going to be any problem for us today, but it watches that flow. And so it'll see that, oh, well, we expected it to flow like this, but it didn't. So maybe we need to go check this part of the river or the creek. And then it can go out there, whenever they, the public works staff can go out there, whenever they can work it into their schedule. So it allows, when we talk about being proactive, you're not sitting there being just reacting to emergencies when there's a big rain event. Instead, you can kind of use those small rain events just to monitor, check the system and make sure everything's flowing right.
Great, Brad. So we really pummeled you with some questions. I'm not sure where you are on your presentation, but why don't you go ahead logically where you think this goes, and we'll keep asking questions as we go.
Sure. Yeah, I've only got maybe 5 more slides, and we can finish it up here. So as far as the implementation of the system here, we made use of the Microsoft Azure cloud and some of the functionalities there. So I know some of the questions were also about how do you tie into the sensors? Azure has a IoT hub, an event hub that's a very good data bus and has good connectivity into gauges and other systems. They have their Logic Apps capability, which allows you to put various, if you wanted rules on things, or like for the AccuWeather, we kind of set, that's where we set the frequency on how often we get the data. And that's something that is all very, there's a lot of skills, a lot of people have skill sets around that. It's very well known. And then also, the SaaS portion, we have our event stream processing, which basically runs all this in real time. And then our analytic modeling, artificial intelligence package. And then the visual analytics is how we do those dashboards in there. So it's a cloud-based environment where we kind of combine the best of a lot of different worlds there. Let's see, some of this I touched on already. I'm just going to talk about the analytics, just to give you an idea of the gauges, that we're using, very similar to what we talked about earlier. The whole idea of capturing the forecast data, this is something that, for even down to our citizens and our, city management and officials, this is something they're kind of familiar with already, because you go into your your local weather TV weather, and they'll do this thing like a FutureCast thing where they show the progression of the storm, and so they can kind of say, okay, well, wow, I can see how I can get that data, and if we can get that data into our system and leverage that, it shows that the storm's going to come through at this time, and here's the rainfall and test intensities that are expected. So we're making use of that, and also it's a concept that people can understand. And then I did talk about these as well. The anomaly detection is a good thing that just is, monitors the system all the time. Whether anything major is happening or not, but it allows us to see what's going on. And then for the when we do have an event that's coming in, both doing those predictions, and then because you've got it at all those different locations, you can basically produce what we call an incident pre-event summary, where you can say, okay, we all know that this is coming in today. Here's what we expect at these different times, and be able to go ahead and get that kind of planning and be proactive. So that's pretty much what I wanted to cover with you all today. This is something that has been working for us here. Gives us new some new sensors, and be able to combine in very localized sensors that we can install ourselves. Use the cloud technology to do a cost-effective solution, and kind of use that IoT and artificial intelligence together to improve the responses and streamline them, and also give more visibility and information to both our operations people and our first responders.
So Brad, 2 additional questions. One is the prediction model running all the time, or is this something that's initiated with each event?
It's
each
running
incident?
all the time. Yeah.
Okay, so it may be just a steady state in most situations. And then one of the things we learned from Terry, who we know really well, just so you understand, I mean, Terry was one of our Readiness Challenge winners 3 years ago. And so Terry is, we were all very envious of Terry's story about going to Mexico December 31st. But one of the things he mentioned to us was that Terry did a design session with a lot of its solution providers, Esri, SAS, Salesforce, Azure. Were you part of that?
Yeah, in fact, that slide near the beginning where we had all the use cases was from that session. So yeah, we did have a whole group of us that were in there, and they provided snacks. So that's the key, I think.
Okay. So we'll have to, if we do it on, somebody had a question. Sorry, go ahead.
Yeah, hi Phil, this is Linda Rebrovic. Brad, I'm the community champion for Metro, and this is a complex but exciting, smart and connected community ecosystem. And so to follow up to Philip's question, did you find that session to be valuable, where they had 6, 7, 8 different solution providers together? And it sounds like for lunch you all will do that, right? but on a serious note, I think, what would it take to get that group together, including SAS, if Nashville wanted to do that?
I would, yeah. Let's. I mean, I definitely think that's a good possibility in doing that. And I guess where I'm thinking is, one thing that as I've worked on smart city projects, and with Philip, I've been a little while since I've been involved directly in some of the Smart Cities Connect stuff, but it's always been a group that from the different vendors are willing to kind of come in and help brainstorm this. One of the things with IoT, and I see this everywhere, is that there's no one vendor who can supply an end-to-end IoT solution. Some people might say they can, but in general, we all realize that there's various different. There's always going to be a group together, and so we do a lot of ecosystem partnership type work, and even know a lot of the different people that we work with at different companies, because we work on projects pretty often. So yeah, that's not unusual in my experience to have a situation like what Terry described for Town of Cary.
And Mike Casey from AQUATIC Informatics said the same thing, that they work with a lot of different partners. I mean, a lot of this is partnership. A big piece of what the council does is not just work with cities, but work with different solution providers to introduce them and get them to work together. I'm sorry, Linda, did I interrupt you?
Yeah, no, I was just going to say, and we'll take you up, I'm sure Nashville will, on the opportunity to get your team involved, Philip, and help put that together, because I just personally haven't been in the business of selling solutions for a long time like this. That design workshop would be tremendously valuable for Nashville.
This is Jennifer.
Jennifer, go ahead.
So Nashville, Nashville already uses Esri as we have our several Metro-wide solutions. So we're already in Microsoft and Azure. So I was interested in the IoT solution that you're using. And we're obviously an Esri enterprise licensing for Esri, so they have IoT solutions out there. And how you chose to go with the Microsoft Azure? Is it because you wanted stuff in the cloud, or?
By the way, Jennifer, just to make it clear, Brad is with SAS, okay?
Oh, he's
Terry
with SAS.
Yates.
Why did the
Yeah,
town
he's
of
with
Cary,
SAS.
I guess, how did they come along with that solution, I guess, then?
Well, I
mean-
can ask Terry. I've been emailing Terry before he heads to Mexico, and I'll ask him that question, okay?
But yeah, so SAS then has interactions with both Esri and with Microsoft already.
Yeah, correct. And, you know, we work with the other public cloud providers, AWS and Google Cloud and such, and even some industrial ones like, you know, Siemens and GE, Predictions. But we've put together a real good partnership with Microsoft for the Azure cloud, and it fits very well for us. So, you know, I definitely recommend it, but, you know, others are available.
Okay, we have Microsoft Azure that we use for our Office 365, and so I know that's a possibility for us.
No, that's a great question, Jennifer. Yeah, and it's the blocking and tackling that still has to be done, obviously, because the solutions are not, I mean, they're fairly obvious. The technology's been around for a while, but it's the application of it and finding the right integration of different solutions. Brad, I can't thank you enough for just allowing yourself to be pummeled very much like Chuck and Mike did and ask questions. But we've sort of developed this approach where it's like, if we don't ask it now, we won't get the answer, right? So, you know, any other questions from, I don't see any more questions from the audience. Any more questions from the Nashville team? If
No,
not,
this is Janie.
ahead,
I just
Janie.
want to say
I'm sorry.
thanks to everyone. Sorry about grilling you with questions. I really appreciate your sharing your information. I kind of see these sessions as a way for us in Nashville to learn from you. So I really appreciate your time and help on this.
Yeah, it's really, Janie's been key to our success with this, and Dr. Camp, I should say. And anyway, Brad, Chuck, Mike, thank you very much for your time, and to the Nashville team and everybody else who's online, have a great holiday, and we look forward to seeing you in January. Thank you.
Okay.